Hello, guys. So, let's start with today's lecture. In the lecture series, Attention and Transformer Models. So, today I'm going to discuss about attention and how does this work and what's the maths behind this. So, let's start. So, in last lecture, we have seen that there are there is encoder, then there is decoder. Okay. And suppose I want to translate a sentence. So encoder will encode into let's say I want to translate English sentence to Hindi. Encoder will take English sentence and decoder will output the Hindi sentence. For example, in the last class we have seen this that let's say there is input which is called this is a book, okay, and here we can see that uh, this is the encoder part where this is a book is given as input, and the output part is in Hindi, which is shown here in green, so which is the decoder network. So Uh, today I'm going to get into depth of it. How does this work and how these weights are calculated. So let's start. So before we start with attention networks, we have to first understand that there are three types of vectors that I'm going to talk about. First is query vector. Second is um, we can say the key vector, and third is value vector. Okay, so there are three vectors. Now, these two vectors come from encoder, and query vector comes from, decoder. And how does attention specifically works is, let's say I have a sentence. This is a book. Okay, so this is the first. This is my first word. This is a book. And what I want to do is I want to generate, let's say, output, which is यह एक किताब है in Hindi, right? Okay. So to generate this first word or to generate the second word, how does this works? First, each and every input is having Q1 and query. Sorry. So query comes from decoder and key and value comes from encoder. So this is having key value and vector value. Key and value vector are same. K2 and V2 are same. K3 and V3 are same. And K4 and V4 are same. So this is key value, key vector and value vector. Vector and value vector. Key and value. So these vectors are same. So key is basically embedding for this, and similarly value is embedding for this. Then K2 and V2 key and value are embedding for is, and so on. Okay. Similarly, on the right hand side, you have query, you have Q2, you have Q3, and you have Q4. Okay. Now, what happens is basically what exactly we want to do. We want to take all the inputs from the encoder, hidden states, okay, and we want to generate a context vector out of all the hidden states, right? So, hidden states, let's say it was H1, H2, H3, and H4, okay. So, what exactly that we want to do is we want to multiply this with some weights, W1, W2, W3, and W4. And how these weights are calculated? So these weights are calculated by multiplication of this query vector and this key vector. Okay, so these two gets multiplied. So weight is nothing. So if you learn the maths behind it, so weight is nothing. It's the multiplication of query and key transpose. So basically the size of, because size of K and Q are same. So that's why to make the dimensions, let's say there are n words. So if number of if the vector K1 is of size n cross m, and Q1 is also size n cross m. So the output should be n cross n, right? So that's why the size of this vector should be n cross n. Okay, so W2 is basically Q2 cross K2 transpose W3. So how these four weights are calculated? We're multiplying query from decoder to key from encoder. This is how all the weights are calculated. Now, after calculating the weights, W1, W2, W3, and W4, these weights are multiplied. First of all, we take softmax, we apply softmax to all these weights. So we apply softmax. Why do we do that is we want weights to be probabilities. I want to give, so to predict, let's say kitab, to predict the second word, third word, I would like to give weightage to previous two words. Okay, so to predict, let's say I want to predict this third word, so I will give weightage to Q2, Q1, and I would also like to give more weightage to a book, right? Out of all, this is a book, right? So, what do we do here is that we take softmax function of this W1, W2, W3, and W4. And how do we do softmax of this is we W1, W2, W3, and W4 are nothing. These are just the distance between query and key. Think about it. If two numbers are same and they are multiplied, then their weight would be higher. If two numbers are different, let's say it was zero point 0.1 and it was zero point 0.9, right? So number would be lower. So it's basically the distance. So distance or the weight, right? Distance. So more is the distance, more lesser is the distance, more weight, lesser is the weight given to uh, uh, lesser is the distance between book and kitab. So lesser is the distance, more weightage we want to give to that word, right? So weights W1, W2, W3, and W4 are nothing. These are just multiplications of query and key, and we apply softmax so that the sum of W1 plus W2 plus W3 plus W4 is equals to 1, which is W4 would have higher probability, let's say zero point 0.6, and W1 would have zero point 0.1, W2 would have maybe zero point 0.2, and W3 would have zero point 0.1. So weights are calculated by this, okay? After that, what do we do is we apply this, we use the embedding this value and multiply it with the original number. Okay, so it would be, it would be V1, V2, V3, and V4. So the formula, if you look at the formula for attention, so formula for attention is uh, attention. So this is the, and then we add this, we takes point was addition of all these metrics. So this is all the metrics. So you will get a matrix of n cross n. Okay. And then what's the formula for this? Attention equals to softmax of query key transpose. So this is the weight, query key transpose and softmax. This whole is the probability or the weight, and then multiplied by V. V is nothing. V is what? This embedding. So this V1, V2, V3, V4 is multiplied by these weights, and then all these are added. All these four are added, and whatever you get is the final attention vector. So to generate the third word, you will take input from Q1, Q2, and all the inputs from encoder. To generate fourth word, you will take input from Q1, Q2, Q3, all the previous words. This is called uh, encoder decoder retention because you are involving all the encoder weights, but some of the decoder weights. For example, for generating second word in the decoder, you are utilizing only first word of the decoder. So this is the whole concept behind the encoder decoder. So I hope this is clear to you. Thank you so much.